forward and the reverse reaction. So this is a very interesting topic, that forward and reverse reaction, how we can identify the forward and reverse reaction. So let's have an introduction about this. In the previous lesson, we have already learned that a reversible reaction consists of two reactions. The first one we have forward reaction, and the second one we have reverse reaction. And why it is known as reversible reaction? Because in this, the reversible reaction can be happened, the reverse reaction can be happened, the forward reaction and the reverse reaction. A lot of examples we have related to the forward and reverse reaction. Let's have an example like A plus B. When they are going to combine and changes into C plus D, this reaction is simply known as the forward reaction. And when the C plus D is going to change into the A plus B, this reaction is simply known as the reverse reaction. So let's have a look that by definition what does mean by a forward and reverse reaction. So forward and reverse reaction, we have the forward reaction. Definition for the forward reaction we have proper. It is defined as the conversion of the reactants into the products per unit time, or the rate of the chemical reaction taking place in the forward reaction. We can say that the rate of chemical reaction that is taking place in forward direction, this we known as the forward reaction, or the conversion of reactants into the products. When the reactants are going to change into the products, this process is known as, or the reaction is known as, the forward reaction. On the other hand, for the reverse reaction. So what does mean by reverse reaction? It is the reaction of conversion of products back into the reactants per unit time per unit time. This is known as the reverse reaction. As I have already explained the example, A plus B changes into C plus D, and C plus D is going back to change into the A plus B. So this is the forward reaction and this is the reverse reaction. Simple. Next, we have some macroscopic properties of the forward and reverse reaction. So let's discuss its macroscopic properties. The first one property is that it is the reaction in which reactants, for example, we have categorized the forward reaction, and the second we have reverse reaction. So first property, or the macroscopic property of the forward reaction, we have this: in this reaction the reactants form the products, and for the reverse reaction we have inverse of this. In this, the products form the reactants. So this is a simple property: reactants changes to products, and in reverse reaction products changes into the reactants. Second property, we have the forward reaction, it takes place from left to right. On the other hand, the reverse reaction is the reverse of forward reaction, it takes place from right to left. The third one property, or the macroscopic property of the forward reaction at initial stage or initial time, the rate of forward reaction it is very fast. On the other hand, in the reversible reaction and in the beginning, the reverse reaction is slow, or we can say that it is negligible. Fourth one macroscopic property is that it slows down gradually. The forward reaction slows down gradually. Slows down gradually mean when the reaction is going to be start, the concentration of reactant is more, but after some time when it is going to change into the products, now its concentration is less and its rate is also slow downs. On the other hand, the reversible reaction it speeds up gradually. It speeds up gradually. It's mean with the passage of time, as its rate is slow in the beginning, but after some time it started to be increase, or the reverse reaction is speeds up gradually. So these are basically main four macroscopic properties of the forward and reverse reaction. Now let's have example for the forward and reverse reaction. For example, we have a reversible reaction. Reversible reaction. The simple example we have is when NO is going to combine and changes into the NO2 by the combination of oxygen. These are in the form of gas phase. This is a reversible process. Now we have to categorize the forward and reverse reaction in this. For example, the forward reaction we can also write it as the forward reaction is when NO combining with oxygen and changes into the NO2. And next we have the reverse reaction in which NO2 is going to change into the NO and O2. So this is the simple example that is going to show the forward and the reverse reaction. So this is the reversible reaction. Now we have to separate out forward and reverse reaction from this. I hope you guys understand about this, and if you have any queries you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz.